an LED light, quite a stylish LED light that appears to be based on an aluminium extrusion with a little power supply just physically banged in the back. First time I've seen it in quite this style, I think. And then what looks like a cob array under a suitable plastic lens, although I'm not sure about the... It's got sort of prisms at the edge. I thought that was to shape the light, but as you tilt it, it just seems to block the light more than anything else. It's quite odd. But anyway, let's do some electrical tests. The first thing I can tell you here, let's zoom down the data on the back of the power supply. The first thing I can tell you is that the earth is not connected to chassis earth, but that's not usually a surprise for these things. It is going into this, so if this is isolated, it might be connected to the output. I'm not really sure. The supply is rated 50 watts, and it says 36C to 50C. That'll be the number of chips in the series. And the output voltage, the input voltage is 85 volts to 265 volt AC, so universal voltage, but the output is 90 to 165 volts DC at 220 milliamps. So I wonder what sort of a cob array that is. Okay, tell you what, let's plug it in and test it. So I shall bring up the Cliff Quick Test, which is this red thing you stuff wires into, and I'll stuff the earth wire in since it, you know, I don't know if it's functional, but we'll stuff it in anyway. The wire is scrawny and horrible. It's very thin. It looks like copper-coated aluminium. It's got that feel to it. And to test this, I shall bring up the Hoppy with its ever flicker display. So we'll plug this in. I shall plug that in here. And we'll give the light a test. This is where it gets very bright. I'll just put that off to the side. What have we got? It's bright. It's a warm white. It says 36 watts. 245 volts is the current supply. 266 milliamps. And the power factor is 0.5, which you'd expect for a switching supply. So 36 watt light. But having said that, that power supply, I suppose it's all right for 36 watts. Just point it at the wall. It is that it's warm white. It's a very pinkish warm white. It's very strange. Right, tell you what, I shall unplug it. It is bright. And let's explore this. So I shall unplug everything and pop it out the way. So the power supply is held on the back with rusty screws, pre-rusted, that's nice, and the end caps are just falling off, revealing the grey potting compound inside. We'll investigate that. We'll see how the earth is connected. And the front has this plastic front screwed on. Let's see how it's sealed. Let's bring in a screwdriver and whip these screws out. Yep. Tight. Oh, very tight. I could have paused while I did this, but there's a certain element of revealing the magic. Revealing what's inside in real time. So these appear to be just tapped into the aluminium extrusion. Is this just suddenly slowed down? This is quite an old cordless driver. This seems to still be working okay though. Is that it? Oh, that is it. Oh, okay, so they've got a flat surface on the extrusion in here that they've put a seal onto. Is that seal something they've separately glued on, or is it something it's possible they've just actually extruded it into this with a machine and then placed that on, because it does have a channel for that. I'm not sure what this prism effect is, because it's matte. They've given it a matte texture inside and it doesn't seem to project out the side too much. Right, tell you what, I want to actually, well, tell you what, let's get the meter in. The things here says 2B50C. I'm going to guess that might be 50 chips, given the number of chips, but with pairs of chips. Okay, let's test from live to the circuitry. Well, let's test on the earth actually and see if anything is actually grounded here. So I'm guessing that the connection that comes in here is actually going straight over to here as well. Yes, it is. And that's going over to there. Okay. Let's go from earth and touch that then. No continuity to Earth. Okay. Is it an isolated supply? Let's swap the probes around and just double check this. No, it's not. I am getting a diode here. That suggests a buck regulator, that there's just a diode between that and the mains, a rectifier. So that looks like a buck regulator with no earth. That's not good. The cable, as it comes in, they've learnt from their lessons, presumably in the past, that the cable itself is if the water can actually get down the inside of these cables. So they've got a silicon, they've actually just tucked the cable through the extrusion. Hold on, let me take a look at the back of what that is. Ugh, what the heck is that? Is that actually a gland? Okay, it's a little cabley gland thing that they've pushed through as a protection against chaffing against the edge. And then they've just basically pooed some silicon around it. Okay. Let's see what voltage this is across this LED strip. So I shall set this up to about 200 volts DC. I shall bring in the quick test again. And if this is 50 chips, I would expect it to be roundabout. Well, I can count the chips. I could pause and count the chips. I'm not going to count them in real time. That would just be tedious. Do I bother even connecting the earth wire? We'll whip the power supply off the back and we'll take a look at what's inside it. That, and that. And we shall plug it in and I shall measure the voltage, which is reference to mains, across this LED array, and that will give us an indication of how many LEDs are in series and parallel. Pow, that's bright. Let's get the meter in. Can you see the meter? Yes, you can. It's very, very bright. Let's probe. 150 volts is round about 50 chips. 50 chips, because it's 3 volts per chip, and that says to be 50, so I'm going to guess there may be 100 chips. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 27, 28, 29, 30, 31, 32, 33. Say, yeah, it's about 100 chips. It's about 100 chips, so there is 50 series circuits of 2 LEDs in parallel in there. Okay. That's interesting enough. It does have heatsink compound. I can see that squishing out the edges. Let's poke that and see if it's moist. Yeah, it's moist. It's the standard white silicone stuff. Okay, interesting. Let's get this power supply off the back. Given that this thing is not electrically safe, let's just lop this off and take a look at the power supply. So I shall undo the rusty screws that hold it onto the heatsink. And I shall chop a cable. Where are my suitable chopping snips? I shall chop it there. Nice. And we'll put that out the way. Smattering of screws falling on the ground. Since this is all kind of depotting anyway. Oh, okay. That's kind of interesting. Okay, so it's a friction fit. The earth wire is just chopped off. Wow, that's so shit. What's under this sort of paper here? That's designed to stop the compound. Well, it's designed so that it can sit into this compound but not short against the case. Is this going to reveal anything, or is it just insulation? Hold on, I'll put the meter out the way. I shall get in closer to this and we shall pick away at it. I don't know how far I'll go in because, oh, there's the circuit board. There is the circuit board directly under that. I wonder if it's still holding a charge. I'll soon find out, although I'm guessing that it is just a... Ooh, right, okay. I shall zoom down. I said I'd zoom down. I did not zoom down. Most remiss of me. This is very crumbly. There's a capacitor. That was another thing that was being kept away from the side of the case. This is very crumbly. Potting collar. Tell you what, I'm just going to pause momentarily and I shall crumble as much as I can crumble and we'll see if we can reveal what's inside. Oh no, tell you what, you know what, it's crumbling off so quickly. Maybe I'll just not. Maybe I'll just keep crumbling. I'm crumbling. If I was going to get a shock, I'd have had a shock by now because I just stuck my fingers right across the main electrolytic. I'd rather have it when I know I'm going to get it. Oh, now it's getting a bit trickier. I may have to pause at this point because this is where it's going to be all potted around the circuitry and the transformer. But right now, what I'm seeing here, let's chop this, is that it's quite a small circuit board inside a very standard case. Well, let's chop that off because we don't like it anyway. Chop that. Where is a picky screwdriver thing? I shall do my best to stay in shot. Famous last words. You know how notorious I am for just wandering off shot. I'm expecting, well, because this is a buck regulator, I'm expecting an inductor under here. This is actually easier to unpot than expected. That almost hints that you could almost possibly, in extreme circumstances of a specialist supply, you could unpot it and repair it. That'd be nice. There's the inductor. There is what looks like a bootstrap capacitor, but it can't be a bootstrap capacitor because it was referenced to the output was referenced to mains by a diode, so I'm guessing this is just a buck. It's got two connections there, but it's got another connections paired, but then it's got another two separate connections. It's possible it could be a very simple buck regulator, but actually with a bootstrap circuit to power the circuitry. There's the chip. Quite a small chip, isn't it? But then I guess, again, because they're using quite a high voltage in the LEDs, the current's low, and that's what really matters for the chips, for the switching transistor. Righty-ho, tell you what, I'm going to see if I can find a number on that chip. That would save a lot of time if I just looked at that chip right now with a little magnifier and got a number. Is it going to be a bright power special? It's not bright power, but it does have a readable number. TA3722. Okay, give me a moment. I'm going to take a look at that so I can find it. Okay, let's take a look at the circuitry inside. The chip is the TA3722. Here's what I found. I found one very grainy picture. That I could not trace that at all. It's very clearly one of those chips used in Chinese ballasts that are, you know, the chip is not available to the general public because it's only for these particular applications. Things worthy of note. This is just a simple inductor. There's no extra sort of winding on it, auxiliary winding. It does have a bootstrap circuit. That's what this capacitor here is for. But this little winding is actually between this pin and this pin, but they are commed in the circuit board just for extra support as these. Well, I took the transformer off. You can see that the tracks just go between the two pins here. We have an incoming supply. There is a tiny little choke fuse here. Basically speaking, this is a plated through hole. The live comes on here, this little zigzaggy trace that just is designed to blow like a fuse, but it then feeds one end of the rectifier. The other end of the rectifier is from the neutral here, which is just called these two pads commoned. There is off camera, there is a electrolytic capacitor in here, which in this case had a rather generous 15 microfarad 400 volt rating. That's quite high. 15 microfarad is quite good. It's notable that it folds down over the hottest component of the board, which is probably the... Well, I'm guessing that. It could be the inductor could get warm, but this chip is switching the load, so this capacitor folds down over that. So again, it's going to bake the capacitor. That's the usual thing with these. So a bridge rectifier, a smoothing capacitor. Unusually, these connections here are actually common to these connections here, but they've put this big island of copper across in the back from here over to there. I'm guessing that's just to keep the resistance as low as possible. Things worthy of note. The bootstrap diode. I'm guessing the freewheel diode, really, for a buck regulator. And then this is the current sense resistor, and if you can see underneath it, there's another little sneaky surface mount resistor tucked underneath, so they're fine-tuning it with two resistors in parallel, but one of them is surface mount, one of them is on the top. This is 2 ohm, the one underneath is 1.8 ohm. And then there's a parallel resistor with the outputs, the LEDs, just probably to make sure they turn off quite quickly. when it's turned off, and also provide a slight load as part of the circuitry. I've marked this blue because this is connected to there, which is connected to there. This is all connected to negative, so the output is directly referenced to the neutral. Well, the negative, ultimately, because the negative is also connected to the live via the diode. And the positive to the LEDs is switched via the inductor. Let me show you the circuitry. Oh, other things I should note. Bootstrap charge resistors. When you turn it on initially, they charge via these resistors. And then once it kicks up, it's via this diode and this resistor to charge the capacitor. And that's the power supply for the chip, as I shall show you on the schematic. The blurry out of focus because, well, it's out of focus for me too, because it's a blurry low resolution schematic. It's a picture stolen from a Chinese website. There's the discrete bridge rectifier, there's the big electrolytic capacitor, there's those two resistors in series charging that little capacitor, which is 2.2 microfarad, 50 volt. That generates the power here. When it's running, the positive being switched through this chip via the inductor drives LEDs, but it also comes back through this diode, through that resistor at the slightly lower voltage to actually drive to charge the capacitor. I'm guessing that means that the output gets shorted or something goes wrong with the output, then it's going to prevent that being charged, and it'll do that bootstrap thing that the LEDs then start pulsing. There's the two sense resistors in parallel. There is the sort of flywheel diode for the inductor, so that initially when the transistor in this turns on, current flows via the inductor, which limits the level at which current can flow through the LEDs. But then when it turns off, you're going to get a slight inductor effect, which it's not the normal arrangement, though. It's very strange. So let's see, this one would go positive and negative. That would then go positive, that would go negative. And then, yeah, it does find another way through. So it's for efficiency. This is the flywheel diode. This is shown as an earth connection. It's not. It's just showing the circuitry negative connection, but it's notable the ground connection is separate from that. It's not connected to that. It's actually right on top of that inductor, which is quite odd. But that's how they've done it. So there we have it. It's a very simple, universal little power supply. I shall zoom back out again because I can bring the light in again. And when they're building this, it's pretty clear that they have the circuit board. They put the paper in as a liner just to protect it from touching the case. They lay the circuit board in, they slide these end caps up to it, and then they just fill it with that splooge, that grey material, which was very crumbly. So I'm guessing it's silicon with lots and lots of filler in it. Let me bring the light up and we'll discuss what could be done with the light. The light as it stands, let's focus down on that just so it's nice and sharp. Let's put something on top and go, focus on that. Focus on that resistor. The light itself, it's a nice housing. It's a nice aluminium extrusion. This metal thing, I'm guessing it's steel, is probably going to rust. Yes, it's going to rust. It looks as though it could be fairly waterproof, just going by the design of the seal here. I'm not sure if that's a separate seal or it's actually been piped into here and then stuck down. It didn't seem to be too hard to take off. If this fails, this is one of these aluminium PCBs. It's aluminium in the back. It's a super thin wafer of the fiberglass, and then it's the LED chips, probably flip chips, are bonded directly onto that. Flip chips are basically the bare LED chip, but with two metallized tabs at the end, so they can flow on like an absolutely microscopic surface mount component, but it is just the bare physical gallium nitride LED chip. They put the dam round, they flooded it with the resin, the squeaky resin. It's interesting that it's got the two connections at that end. I suppose it means they could connect to the other end, or they could connect them along in a sort of large parallel array. But with these thin fiberglass layers, when these chips fail, they often burn up inside, and they sometimes burn their way through that and then make a path onto the back of the metal and then onto the metal casing. So this is not earth. The earth was completely fake. The wire went into the resin and was just chopped inside the resin. It's basically a stealth fake earth. So that means that the metal body could become live in these. It's just something to consider. But as a housing, if you can get past the fact there's divots missing out of it, you could either How spacious in the back? Not really spacious. It is quite a lot of heatsink finning. You could get 12-volt LED cobs, put them on for vehicle use, or even just individual the Luxian Star style LEDs, and you could put them along it as well. Even the 10-watt 3x3 LED little 10-watt LEDs used in some floodlights, they could be put in and run with just something like a resistor and a 12-volt supply. So it's a nice enough case, but unfortunately the power supply, while being functional, the earth is completely missing. It's not safe in that aspect, and ultimately it's going to suffer the fate that these cobs usually do. It's probably going to fail at some point, and I'm sure that water would probably get in, given the thermal cycling of fitting that was running about 30 watts. That's quite a hard silicon. That's quite interesting. But there we go. It was quite fun and interesting to take apart. Do I recommend it? Not really, unless you just want a nice chunky case that can be adapted for other purposes.